Okay, good morning, everybody. So I think we're still waiting on a few folks to trickle in here, but our plan for today, and unfortunately we are going to have to split it up into two parts. I'm still working on a solution with Greenville Tech to get Zoom so where we can like go past 40 minutes. But just like we did last time, we can just split it up into two. I'll post both of them to our class YouTube channel so you guys can go and watch those lectures if you want. So let me pull up the chat here. Okay. So same protocol as last time. If y'all have a question, you can ask it. Just turn your mic on and ask it, or probably the more efficient way would be to ask it in the chat. Plan for today, in the first part, we're going to get through the rest of chapter 1 as close as we can to it anyway. And then we are going to wrap it up in part 2 and then do a Kahoot quiz, our first Kahoot quiz of the semester, which is very exciting. And we use the Kahoot quiz to take attendance. So, and how that's going to work, if y'all used a Kahoot before, it's pretty straightforward, but it'll give you a code and you guys can just type it in and we can do that collaboratively. It's good because we can talk about answers in real time and get you guys practice for test questions, which is very important. Okay. Share my screen. Okay, so going back to welcome. All right, so this is where we left off-ish. I'm just gonna finish it from here. Me down here. There we go. Good stuff. Play slideshow. All right. So developing a hypothesis. What's the difference between a research question and a hypothesis? Because this is going to be your assignment for the weekend. I will go over it a little bit either tomorrow or Friday. But a research question is very broad. A hypothesis is typically very specific. So if you've ever done something on the scientific method, hypothesis is basically a prediction. If this happens, then this will happen. It is what we are testing in an experimental setup. So a theory is actually a collection of hypotheses. So if you think about like gravity, so gravity a long time ago, gravity was a theory, and then a lot of people tested that theory with various hypotheses. So you have your big overarching thought of a theory, like the Earth is flat. There's a theory for you. But then you can test that hypothesis in a variety of different, you can test that theory in a variety of different ways, which would be classified as a hypothesis. Sorry, I'm still letting folks in. All right, so next we'll go to slideshow, please. Okay. An operational definition. It's pretty much exactly what it sounds like. It's just a more precise definition that we can use in like a scientific paper, just to make sure that we are being specific about what we say, because that is a very important part of science, so that people can get back to using exactly what we talked about. So some terms that we use can be kind of ambiguous. So like if we talk about, if we are studying something like attraction, we need to define exactly what we mean by attraction, because that obviously in different contexts can mean different things. So instead of just saying, we could be talking about physical attraction, we could be talking about like smell attraction. So if we're like studying some type of like perfume, if we're testing a perfume that we want to sell on the market, that's a type of attraction. If we're talking about like magnetic attraction, that's obviously relevant if we're studying magnets. That would be a type of attraction. So you need to define that term just to make sure everybody's on the same page. And so when gathering data, researchers must remain objective. So that's a very important point, because especially if you are like, think about like a pharmaceutical company that's testing some fancy new drug that's going to cure baldness. So if you have a drug that you think can cure baldness, you are going to be slightly predisposed, or very predisposed, because you got some skin in the game, to that hypothesis being proved correct. And so that you are now no longer objective. So to have good research, it needs to be objective. You need to remove any of your own personal bias from that research, just to make sure that we're actually testing the thing that is trying to be tested, and only that. And how we do that is fairly complicated, but we'll talk about it. It's tricky, I should say, not complicated. But we will go over that plenty. So there's a difference between descriptive statistics and inferential statistics. So descriptive statistics, just like the name suggests, is just kind of describing data. It's not trying to make any big statement about it. Inferential statistics is kind of that next step, where you are trying to make some sort of meaning out of the data that you've collected. And the question that we always ask is, did the results support the hypothesis? So that goes to a question of something called internal validity, which we'll talk about a good bit over the course of the semester when we look at research. But yeah, descriptive and inferential. Descriptive, there are a few different types of descriptive research methods that we'll talk about, survey, and then a few inferential ones as well. And sharing our knowledge. This is also the way that we find knowledge that other people have come across. So peer-reviewed publication, so something like a journal, and then public presentations at conferences. So we talked about the scientific method and how most of our questions start with somebody else's answers. And so the way that we get to those answers is by sharing what we've learned, and then other people will pick up on that and take the next step forward with it, ideally. All right, ethics. So we have talked about sort of making this circle. The research just goes in a big circle. You start with developing a question, then with publishing the findings, and then somebody else asks a question based off of your findings, and then we go back to the beginning until we have all the answers, which is actually never going to happen. So one of our goals of this course is to develop our critical thinking skills, especially in how to determine what is good research and what isn't, what you should include in a paper, what you shouldn't. So we'll dip our toes in those waters with our assignment for this weekend, but I definitely am trying to get you guys to think more critically about research that you're presented with. Okay, talked about twin studies. Okay, so just go to camp out here for a second. A lot of the stuff in the book, like I'm not going to ask you about like these two twins on a test, but a lot of stuff in the book is good sort of like background information to kind of flesh out what we're talking about. And so we talked about these guys at the beginning of last class. Their specific case isn't that interesting. Well, I mean, I guess it is interesting, but it's not that relevant to like our course questions. But especially the questions they ask at the bottom, like what variables might psychologists interested in twins, choose to study. Things like that are relevant. Sorry, I heard a noise. It was just my dog chewing on a bone. Okay, so we talked about population and sample. All members of an identified group is a population. So think about the population of our class is everybody in the class. And then a sample of that class, because a lot of times if we're taking something like a survey, it's hard to get everybody. It's hard to get everybody to be on the same Zoom call at the same time, much less get them to answer a survey. And so to try and understand something about the entire group, we would take a sample. There's a couple different types of samples that you can take. The most objective one is a random sample. So I would just say, okay, I need 8 of you guys to participate in the study. I would say, all right, computer, pick me 8 people. And it would pick me 8 people, and it would be random and objective. The issue is that if we have 20 people in our class and 13 of them girls, and the computer picks me 9 dudes out of 10, that's obviously a problem in terms of how representative that sample is of the group as a whole. So the goal is to try and find a balance between objectivity, and random sample, and the sample being representative. I'm sorry if that noise gets distracting, but my dog is playing with her ball, because this is usually around the time that we go on a walk. But I'm teaching class, obviously. Okay, talking about all these PowerPoints up here, all these questions are good, but we do not have a ton of time to go over them in depth. But a lot of those questions will be represented in our assignments. Okay, descriptive research methods. There's a few types. So we're trying to explore a phenomenon, not trying to make a causal connection here yet. We are just trying to explore something new, or just get a lot of data in a short amount of time. So let's say somebody was trying to study how effective remote learning is in an early college situation. There's 4 ways they could do that. They could naturally observe one of our classes. So we could have somebody hop on our Zoom calls week after week and take down their observations. Like I said, that's not going to be super causal. It's really just journalistic in a way, just trying to chronicle what's happened, and learn from that environment. They could also, hone in on one of you guys and make a case study and say, okay, well, how did remote learning affect this person? How did this person do? That's good for expanding our knowledge about what might be happening, but it's obviously difficult to extrapolate. It's difficult to say, well, this is this person's experience, so that must be everybody's experience. That's quite dangerous, but people tend to do it anyway. Survey method. So, if I were to just ask you guys a very simple set of questions, like, what do you think about remote learning? Have you learned as much as you had in other classroom type class settings? Ask you very simple, straightforward questions, and then send you a survey, collect that data, make a chart out of it. But even then, I don't have any huge cause and effect information there. And then probably the most informative one here is a correlation. So if I were to ask everybody here what their favorite color was, and I also asked somebody, also asked you guys what your favorite college football team was. If I found that I had a lot of people who said their favorite color was orange, and then also had a lot of people who said that they were Clemson fans, there will be a correlation between those two things. And so we don't know if those are causal, but all we have established there is that there is some type of connection. We don't know how strong that connection is. We don't know exactly. We're not really exploring anything past that, but we are just establishing that there might be a connection. Hold on 1 second. Stop sharing and see if there's any questions. Anybody have any questions? You can put them in the chat if you have them. No? All right, let's keep going. Oh yeah, we're doing good. Okay, so ignoring the case study because it's not super relevant. Survey method. So gather data quickly. So if you've ever taken something like the census, which I don't think you guys are eligible for yet, but wording of the questions can lead to people answering them a certain way. People tend to like to represent themselves as favorably as possible in surveys, which kind of skews the data, but that's just kind of who we are as humans. And the researchers can also lead them in a certain direction based on how they ask the question. Participants lie, like I said earlier. You also, this one here down here at the bottom is very important. Low response rates. So especially from certain demographics may lead to a non-representative sample. So if you have, if something like the census where hundreds of millions of people are being surveyed, if one particular group is has a much larger response rate than others, that particular group's voice is going to be heard a lot more. And there's a number of different reasons for that. So if there's people that stay at home or are old and are retired, don't have like jobs to preoccupy them with that would prevent them from filling out the census. So people in those kind of demographics tend to be overrepresented in the census, which is bad because that's how we determine like how many congressional seats states get. So think about that next time you get into a political debate. Okay, so an example of this is digital hypocrisy is the name of this case study. So 1,800 parents, children of age 8 to 18. So we're surveying their parents. Parents spend an average of 9 hours and 22 minutes every day in front of various screens. Okay, so how did we find that? We surveyed them and asked them how much time they spent in front of a screen, and then got an average from that. Of those, nearly 8 hours are for personal use, not work. Okay, so we have 8 hours out of 9.5 hours that are used for personal stuff, not work. Now, we also have those same parents, same set of data, saying that 78% believe that they are good role models for how to use digital technology. Okay, so we have the same people who are saying that they goof off most of the time, they're on their computer during the day, saying that they are good role models for showing their kids how to use digital technology, and that technology can be used to support their kids' education. So people tend to see themselves in very favorable light, even if the data disagrees with them. Okay, so this is an important part. A correlation is an association or relationship between two or more variables. Okay, so if you've seen, we'll see how this gets represented graphically. It can be positive or negative, or it can be nothing at all. So a correlation coefficient, this is about as mathy as chapter 1 is going to get. So it is the statistical measure, which is symbolized as R, indicates the strength and direction of the relationship between two variables. Okay, so it goes from -1 to 1. Those are the absolute strongest correlations you can have. So if you think about, for every X, there's one Y. The closer to R is to -1 or 1, the stronger the relationship. The closer it is to 0, the weaker the relationship. And this makes a lot more sense when you see it represented graphically like this. Okay, so this one, the top right here is a perfect positive correlation. So you can see on the graph, if the x-axis is 6, the y-axis will also be 6. It's got the perfect slope of 1. You can see the negative correlation is the exact opposite, so it's going to be -1. No relationship just looks like a bunch of random points because that's exactly what it is. And then a strong positive correlation, you can kind of see that line of best fit that's cutting through those points. That's the graphic representation of that correlation coefficient. So what this means in practice is there is a connection between these two things. We have not established whether or not this one thing over here causes it, but there is certainly appears to be a connection between them. So it's plausible that more people in the upstate part of South Carolina would like the color orange because they like Clemson. There's a potential correlation between those things, but we don't know if there is a direct causal relationships. All right, so there is one of the reasons that we don't know that is there is this idea called a third variable. So unaccounted for characteristic of the participants, their environment that explains the changes in the two other variables. So it could be due to something completely different that we haven't controlled for, that we haven't looked at. No matter how, this is a very important point, no matter how high the R value is or how logical the relationship seems, it does not prove a cause and effect connection because of these third variables. Okay, so in some cases, causality can go both ways. So it's not X leads to Y, because Y could also lead to X. So the example they use here, don't love this, but there is some statistical data to back it up. Exposure to violent media and aggressive behavior. Okay, so if you watch a lot of, Law and Order SVU, you would be more likely to commit a heinous crime, I guess, is the idea there. But also it could go the other way. If you are a person who's prone to committing heinous crimes, you might watch more Law and Order SVU. Who knows? That is kind of the idea there. Okay, experimental method. So we're here to the gold standard. So everybody has heard of a scientific experiment. What does that actually mean? Okay, so we are trying to investigate the relationship between two variables. Okay, so an independent variable, which is the one that we're going to control, and then the dependent variable, which is our result. So the researchers assign participants to two or more groups that they try to make equivalent with respect to all variables, with one key exception: the treatment or manipulation being studied, otherwise known as the independent variable. Random assignment, an important thing to keep objective. Appointing study participants to experiment or control groups, ensuring that every person has an equal chance of being assigned to either. So we'll talk about why this is important, but the experimental control groups have to be the exact same up to the point that one gets the intervention and one doesn't. Okay, and so the experimental group, as you can see here, you can see these two mice over here on the left that are just kind of chilling. Everything's fine with them. And then you can see the other ones that are like going a million miles an hour. So let's say that we were trying to study the effect of caffeine in this experiment. So our guys on the left are the control group. So these mice are functionally exactly the same. So same age mice, same gender, all that kind of stuff. The only difference is that one got the caffeine and one did not. So the control group is on the left because they are the participants in the experiment who are not exposed to the treatment variable. They didn't get the independent variable. So we are comparing the people that did, or the mice that did in this case, to the ones that didn't. The ones that did are the experimental group. So they are exposed to the treatment variable. They represent the treatment group. And with the idea being there that the only thing that changed is the caffeine. So we can, logically say that the caffeine was the thing that made the difference. So independent variable, IV, variable manipulated by the researcher to determine its effect on the dependent variable, which is the characteristic or response that is measured. So the result, basically. So there are other variables in experiments, extraneous variables. So let's say, going back to our mice example, that one of these mice is like super old and is a lot older than the other ones and may not be in as good a health. So that would be an extraneous variable because that could be affecting how that particular mouse is affected by that caffeine. And it could unexpectedly influence the outcome of the study, which would then turn the age of that one mouse into what we call a confounding variable. So confounding variable, if you can think of the extraneous variable as kind of the Pokemon evolution. So extraneous is sort of your Charmander. Confounding variable would be a Charmeleon. Don't know if y'all are old enough to get that joke, but that is basically the idea here, that at a certain point, if it does affect the results of the experiment, the extraneous variable becomes a confounding variable. And there's a bunch of extraneous variables in every experiment. You have to control for them, which is how we minimize their influence. We control variables. We make sure that all of our mice are the exact same age and levels of health, and that we treat them exactly the same, because to go back to our experiment earlier about our big drug company testing their drug for baldness, if I am trying to show that my miracle pill works super well and I pick all people who have hair, that is obviously not going to represent my data accurately. So I have to treat, and if I'm just like much nicer and much more encouraging and much more helpful to the people in my experimental group because I want them to succeed, because I want to succeed, I have obviously introduced a lot of bias into that experiment. So one way you can cut down on this is doing something called a double-blind study. So a double-blind study is where neither the experimenter nor the participants know who's in which group. Okay, so a single blind is the participants don't know if they're in the control or the experimental group. Double blind is nobody knows. Okay, so that obviously increases objectivity because to go back to our earlier discussion about the experimenter, we don't know who's in which group. We can't, give them preferential treatment because we have no idea if they're getting the intervention or not. They might be getting a placebo, which is an inert substance given to members of the control group. Probably heard that term before. Fake treatment has no benefit, but it is administered as if it did, okay, to try and eliminate any kind of, a positive effect that, believing that you're in the treatment group might have. So this is, I would just Google this on your own. It's an interesting study. This guy thought that he had taught his horse to read, but what the horse had actually done was just learn to read the guy's facial expressions. So it's a way that researchers can sort of, believe in their own experiments so much that they cause them to come true, even if they weren't. Okay, so this is one of the best examples you will get all semester from the book. Okay, so we had 64-year-olds, not 64-year-olds, 64-year-olds, most of whom came from white upper middle class households. So we've got our sample here. Random assignment, so they got put in groups randomly. So good objective measure there. So one group watches 9 minutes of SpongeBob. One group watches 9 minutes of an educational program. Think like Sesame Street. And then both groups draw with crayons and markers for 9 minutes. And at the end of those 18 minutes, they are given tests of executive function. The results was that the children in the SpongeBob group performed worse. Now, I resent that deeply because I have watched a lot of SpongeBob and I feel like I turned out fine. But one thing that you guys can think about is what extraneous variables might exist in this study. So I will give you a couple, because I don't know if you've ever met a 4-year-old, but we don't know the kind of age range between these 4-year-olds, because there's a lot of developmental difference between a 4-year-old who is 4 years and 1 day old and a 4-year-old who is 4 years and 364 days old. It says most of these kids came from white upper middle class households, so not all of them. So their upbringing could have caused a discrepancy in that data, because some of them might have been a lot more familiar with executive function tests, or some of them might have, been used to watching SpongeBob. We also don't have any control for like learning disabilities. So if some of these kids have ADHD, asking them to do tests of executive function after, sitting still or after, doing a bunch of other stuff for 20 minutes is going to be very difficult for them, regardless of whether SpongeBob was involved or not. Right, so this is just and I would challenge you guys to think of a few of these on your own, because it's a good example of how studies work. This is just a chart giving you a definition for descriptive, correlational, and experimental data. It's very good, talking about advantages and disadvantages of all of them. So we're going to talk very quickly about ethics. Okay. Do no harm, safeguarding welfare, responsibilities, maintaining accuracy. All this stuff is very important, but the ones that we're going to talk about the most are informed consent and debriefing. Okay, so informed consent, somebody has to know what they're getting into. So you can't just hoodwink someone into hopping in on your experiment and saying, oh yeah, we're doing this thing. We're actually doing something else. They understand what the participation will entail, so nobody's getting surprised by this. And then debriefing, if you don't tell them up front, you are obligated to tell them after the fact what you were doing, because that is the ethically correct thing to do. Confidentiality is also important. So it's protecting research data from misuse or theft, just so people aren't getting implicated in this in like job interviews later down the line. And then therapists are obligated to keep client therapy session information confidential. There's a lot of different rules and regulations that establish that. And thankfully, we're going to talk about a lot of experiments that don't adhere to these guidelines to various extents. But there is oversight provided by this lovely institutional review board, the IRB, that you have to submit all of your studies to before you conduct them. Okay, to positive psychology, which we'll talk about later on. And yeah, okay. So that is the end of chapter 1 lecture-wise. Well, let me get out of here so I can Stop sharing my screen. Now is the time, if you guys have any questions, to ask them. So we're gonna take like a few minutes to ask questions, and we're gonna take like a 5-minute break. And then we will hop on the second Zoom call and do our Kahoot quiz. So if anybody has any questions, I'll have the floor for a minute.
Can you help me with my Blackboard?
That depends. If you wouldn't mind sending me an email, that would probably be the best way to get that sorted out, because there's a lot of different issues that could be happening there. I probably won't be able to help too much in this setting.
All right, thank you.
Yeah.
Excuse me, I have a question.
Yeah, go
What
ahead.
time does the meeting end?
Technically 10:15. We're probably not gonna bump up against that too often. So today I'd probably say like 10-ish.
Okay. Yeah. Okay. Thank you. I was just saying because like we all have school at like
Yeah.
early.
Okay, so we're gonna hop back on at the same link at like 9:25. Okay, so I'm gonna take my dog out because I think she has to poop. But yeah, we will all get back on at 9:25 and we will do our Kahoot quiz. Ready and break.